We just did backpropagation by hand. Now watch PyTorch do the exact same thing for us, automatically, with a tool called autograd. We start with the same little setup from the concept video, one weight, with value 0.5. The one special part is requires grad equals true. That tells PyTorch, please track this number, because later I will want its gradient. The input is 2, and the true answer is 1. Same numbers as before. Now the forward pass, line by line. The sum z is w times x. The activation a squashes it. And the loss measures how far a is from the truth. As each line runs, PyTorch quietly records this graph on the right. It even remembers the value at every step. Half, then 1, then 0.73, then a loss of 0.07. Here is the magic line. Loss.backward. With those two words, autograd walks that graph in reverse, doing the chain rule for us at every step. And out comes w.grad, the gradient of the weight. It is minus 0.21, the very same number we found by hand. PyTorch never gets the chain rule wrong, and never gets tired. Now we take the step. We turn off tracking for a moment and nudge the weight downhill. W minus equals the learning rate times its gradient. Because the gradient was negative, the weight moves up a little, from 0.5 to 0.521. A tiny step, but in the right direction. One more line that beginners always forget. We clear the gradient back to 0. Why does this matter? Because PyTorch adds new gradients on top of the old ones. If you forget to clear them, they pile up batch after batch and your training quietly breaks. Clearing the gradient resets the slate, ready for the next round. In a real program, you do not write the step yourself. You hand your weights to an optimizer, and it does the update for you. Every batch, the same 3 moves we just learned. Clear the old gradients, call backward to fill the new ones, and step to update every weight at once. That loop is how every deep network on Earth is trained. So autograd is the engine under every training loop. You build the forward pass, and it hands you every gradient for free. Next, we will use this loop for real, and learn how to keep a network from simply memorizing its training data.